Hey there, and welcome to Decoding the Digital Lab with CSols, the podcast that asks the hard questions about what's going on in your laboratory. I'm your host, Megan Pettyjohn, and in this series, we're talking with labs to learn the current issues they're facing. In today's episode, we'll dive into the chaotic reality of modern lab automation, where the rush to innovate often leads to unmaintainable technical debt and massive security leaks. If your lab is experimenting with the use of AI without too many boundaries, you'll want to stay tuned into this episode. Joining me is Tony Lisi, a senior engineer at Incyte. Tony has a software development background in Java with Spring Boot, Angular, Ruby on Rails, React, and React Native, as well as extensive experience with LIMS software solutions like StarLIMS, LabVantage, Apollo LIMS, utilizing on-site and cloud-based platforms. Hi, Tony. Thanks for joining me today.
Thanks for having me, Megan. Glad to be here.
Absolutely. Now, as I just mentioned, you have a lot of development and LIMS background. How did that lead you into the role you are in today?
Hey, so I've always been interested in chemistry, and growing up, I was a curious tinkerer. So combining that with my interest in computer science and my desire to interact with the physical world, I found myself drawn to working in labs and collaborating with the brilliant minds in the laboratory informatics space. And to this day, it inspires me to find solutions to support that space.
Nice. Now, with your background in both the code and the chemistry, what are the patterns and challenges of implementing a robust LIMS or even selecting a vendor?
Yeah, so labs like programming environments often operate with multiple systems. It's very common to see different LIMS platforms in use across a single organization, sometimes even for multiple vendors running in parallel. But that ideal all size fits one, or the one size fits all holy grail solution can seem far fetched, just like the sacred object sought by the knights. Vendors tend to specialize in small molecules, others in biology or large molecules, and some focus in manufacturing and others in research and development. So, with organizations spanning all of those domains, there's no real single system that typically meets every requirement effectively. So, as a result, companies adopt multiple systems aligned to specific needs, which reinforce the importance of integration rather than consolidation.
So you mentioned that it's nearly impossible to find a one size fits all vendor for modern labs. When a lab is forced to use disparate systems, what is the biggest integration tax they end up paying in terms of efficiency?
So, achieving a one size fits all tool while maintaining productivity can be very difficult. So trade-offs are inevitable, whether that means too many clicks, slow performance, or forcing customization beyond the tool's intended design. The result is labs typically adopt multiple best-of-breed solutions from great vendors. This makes integration a crucial part of the overall solution. Some labs, for some labs, integration involves consolidating data from separate systems into a data mart for analysis. Other requires tighter integration workflow. For example, enabling a LIMS to communicate directly with an ordering system or an ELN system, and sometimes a solution to create one true layer or hub that connects everything, or create multiple micro apps that do small jobs um, is needed.
Even with great vendor software, you argue that there's always a need for custom applications. Where do you see these micro apps making the biggest impact in tightly integrating labs workflow?
So the integration control software often lacks robust integration capabilities, for one example. So at the same time, lens and the labs tend to keep instruments in service well beyond their life cycle or their supporting hardware or software. So for example, systems running on outdated operating systems that cannot be upgraded or paired with newer hardware. So functionality can be limited, and there are very few players in this field. Uh, but they're growing too. In the meantime, in many cases, the software can only upload files such as sample lists or require manual data entry. So capability issues also arise when legacy operating systems cannot support modern LIMS or integration agents. So to bridge these gaps, labs often rely on macros or lightweight Windows applications, or what we call micro apps, to reduce manual effort. In some cases, licensing costs can further drive labs to develop in-house solutions. With the increased accessibility of AI-assisted development, these small task-specific applications can become significantly easier to create.
We're seeing a surge in what people call vibe coding, rapid development fueled by AI. How can a corporate environment allow for the fast paced innovation without letting it turn into a technical debt nightmare?
So it's become very easy for non-technical individuals to build applications using AI. AI can create very polished, pretty looking UIs that appear to work very well. And in many cases, they do at the surface level. The problem is that AI often cuts corners, which leads to code that isn't scalable or structured properly, which in fact can create a lot of technical debt, which is what that is.
If a lab already has rogue developers using AI to build tools, is it too late to rein them in? What is the first step in communicating standards to a team that is already moving at 100 miles per hour?
Yeah, so telling a lab to stop what they're doing can be very counterintuitive. It risks alienating people who have invested a significant amount of time improving efficiency. A more effective approach, I think, is to introduce structure without disrupting momentum. The first step is to centralize all code in a version controlled repository such as Git or GitHub. That is one of those vendors using Git, utilizing Git. From there, establish clear documentation covering how each application is used, deployed, and maintained. Next, you can implement a basic development standard. This doesn't have to be overly complex to start with. So introducing a simple review step can help identify security risks and improve code quality while also educating those developers. So over time, this also serves as a training mechanism, helping contributors adopt best practices that make the code easier to maintain and less prone to issues. The ultimate goal is to incrementally improve governance, security, and sustainability without undermining the progress of the lab, which they've already made.
AI is incredible at spinning up an initial page layout or a service framework, but you've noted it lacks an understanding of tight standards. What is the specific danger of relying on AI's version of best practices instead of company specific ones?
So here's an example. Database integration or interactions are frequently handled poorly, such as embedded raw SQL directly into API endpoints instead of isolating those queries. That approach can introduce serious vulnerabilities like SQL injections. But again, it appears that this is in most cases the default standard of AI code generation unless specifically prompted otherwise. Another issue is hard coding sensitive information, things like passwords or API keys directly into code. And then once that code is committed to a repository, those secrets become exposed to anyone with access. And generally, you do give a lot of people read access to your repository so they understand or could look into that code if they have questions. So that could include consultants, developers, who should only really be working in lower environments, but now they have that visibility into sensitive credentials. So while AI significantly lowers the barrier to building applications, it also increases risk if development practices around security and architecture aren't followed. And I would say it's very important that the user or the AI understands this and you correctly prompt for this when generating code through AI. I wouldn't frame them as company specific best practices so much as general coding best practices. For the most part, these principles are consistent across applications and environments. So while AI is very, very effective at generating code quickly, it doesn't inherently optimize for long-term maintainability.
Okay, so it sounds like AI really just follows the user's prompting and, if not careful, can cause some headaches. So, how do we balance the speed of AI code generation with the need for long term maintainability?
So AI is effective for quickly generating pages, services, or queries, like we've said previously, that generally follow standard patterns for a given language. However, for smaller changes, manual updates um, are often more efficient. AI tends to modify more code than necessary. Even code it previously generated, sometimes it doesn't like, and it'll change like every line that it created, which increases the risk of introducing more bugs and forces more extensive end-to-end testing for relatively minor changes. So a more practical approach is to use AI to generate targeted code snippets, then adapt them to align with existing standards, database models, and application architecture. So while AI accelerates initial development, it often does so without regard for long-term maintainability, which can lead to increased technical debt and in some cases, an unmanageable code base.
Okay. Sounds like AI is a master of syntax, but does it understand true business logic? Can you give us an example of where an AI generated solution might look perfect on the surface, but fail miserably when integrated into a complex lab system?
You're right. AI really truly doesn't understand business logic. And unless your IP is out there in public, which most companies are not because it's IP, or if you have your own machine learning language in house, it's not going to be able to find that business logic. So, code that it produces may work in isolated scenarios, but can fail in more complex systems, particularly during integration where deeper domain understanding is required. Because of this, you need to be very, very good and detailed at prompting, or you will need to manually tweak the generated code in order for it to work with your business rules.
So I'm sure you're seeing non technical individuals using AI to build functional looking UIs. Beyond just bad code, what are the serious security risks like SQL injection or hard coded secrets that that keep you up at night?
Right. So, if it's just like anything else, if you don't pay for a license, you're the product, right? So, your code that you pass into the prompts could be used to help train AI models um, for the public, and they likely will retain anything that you pass into the prompts. So, you could accidentally pass data that should be private or is IP of your company. Um, this is a larger risk from internal practices than the external risks that you might think of. So the concern really isn't malicious actors, but it's inexperienced developers operating with excessive access. If someone is testing directly against production and has credentials, a simple mistake, such as an incorrect query or an update, can unintentionally modify or delete data. And because these changes may not be immediately visible because AI is doing the work, issues can go undetected for an extended period of time, making root cause analysis and recovery significantly more complex. The longer the delay, the greater the impact on data integrity and the effort required to restore or reconstruct accurate records.
Okay, wow. I love that. If you aren't paying for their product, you are their product. I feel like that is a saying that should be etched along the top of all business walls. So, because of that, do you feel like a corporate's AI license should be a non negotiable when it comes to protecting a company's IP and data privacy?
Yeah, of course. I think AI licensing should be treated as a necessity, but adoption should be structured rather than unrestricted. Organizations benefit from embracing the technology with defined guardrails, similar to any other emerging capability. So, training is a very critical component. Employees using AI tools need guidance or appropriate use limitations, and risk areas such as security, data handling, and code quality. So access should not be unrestricted. Instead, tools should be aligned to their specific roles. For example, developer-focused tools like GitHub Copilot are appropriate for engineering workflows, while tools such as Microsoft Copilot could be better suited for administrative or productivity tasks. A role-based approach improves effectiveness while reducing the risk of misuse or unintended consequences.
I know you're a big fan of using AI for code reviews and edge case testing. How has integrating AI into the GitHub workflow changed the game for your team's speed and quality control?
Yeah, I'm a huge fan of AI. It helps me in my daily tasks. It helps me in my personal tasks. It helps me in my professional tasks. Um, if you can't tell, I used AI even today to help me refine my answers to some of the questions that we are going to be asked, that I was going to be asked. And you're correct. I am a huge fan of using AI for code reviews, as it accelerates code reviews by surfacing issues that might otherwise be missed without extensive end-to-end or edge case testing. So used appropriately, it can increase teams' productivity without increasing the headcount. That can help control costs and improve efficiency. So, but on the other hand, over reliance can also introduce risks. Excessive dependency on AI can reduce code quality, obscure underlying issues, and create long-term maintainability challenges. So I think using a balanced approach, leveraging AI while maintaining oversight and discipline is still very necessary.
All right, as we wrap up, we like to ask our guests one final question. So, as our expert guest today, can you share one key tip or piece of advice you'd offer to our listeners who are looking to rein in the security risks that AI presents in the lab?
Right. So I would say don't use AI as a black box. Don't just take the code AI produces and put it in production. Please use an experienced employee to review all AI code generated before promoting it to production, and even before committing the changes that AI gives you to a Git repository. Because while AI is amazing and it's super awesome and it's very smart, it's still far from perfect.
It's true. Has a lot more learning to go. Well, that is all the time we have for today's episode on Decoding the Digital Lab with CSols. Please join us next time and hit the follow button if you're enjoying this content. We also have a newsletter that highlights current events on a weekly basis. It's free to sign up for. You can get the link to the subscription in the episode bio on Spotify or YouTube. Until next time.